the screen share UI.
Oh, I see what you mean. Yeah, you
Yeah,
can.
okay. It's there now. Um,
14 people, not bad. We'll give 2 more minutes and then we'll start at 7:05. People, you know what's funny? Like our first announcement, we made an announcement that we're making an announcement, and we said mark your calendars, but we didn't provide a date. We got roasted in the chat so hard. And then the second day, we
Also,
both.
sorry to cut you off. Just a reminder to everybody to download the asset pack. I'm not sure if Fayaz put it in the CSHUB server, but there's a little zip file with some images that we're going to be using for our game today. So
Yes, I did put it in the, and now I think it's in the announcements in CS Hub, but let me double check.
all right, just to make sure that everybody's on the same page. Mhm.
Academics, social. Oh, what's this? It's not letting me send. It might contain virus. Jaden.
It's just a zip. Well, yeah, Discord says that about every zip file, but it just has 4 images in it.
Yeah, there you go. Yeah, you guys should see it now in the CSUB announcements.
Yeah.
It's here's the asset for the workshop.
All right. It's 7:05, so let's get started.
Wait, hold up.
Oh,
Before you
sorry.
start, sorry, 1 second, Jaden. I think if I'm not mistaken, now you can send stuff on Zoom too, right?
I'm not sure, but if you
Can someone confirm
say
that?
so, is that a thing? I don't see anything myself, but
Let me just drag this here and see if I can. Access to file restricted by our account admin. Wow. Okay, you know what? Yeah, it's in the CSUB announcement then.
all right. So yeah, please make sure you download the asset pack so that you can have the assets that we'll be using today. Um, Hello everybody. I guess it's beginning now. I'm Jaden. You probably know me to some capacity as the CS Hub president. Today we're collaborating with the Computer Science Club to teach you about the Godot engine. So let's get started. First things first, I'm going to need you to download Godot. You can get it from godotengine.org. I'm pretty sure is what it's called. You can just download the most recent version. Any version of Godot 4 will be compatible with this workshop. So as you download that, I prepared a little slideshow to go through to talk about the Godot engine a little bit. So what is the Godot engine? Godot is a free and open source community-driven 2D and 3D game engine. But what does that mean? What is a game engine and how does it differ from other game creation tools? I created this little graph to represent the idea of game engines versus game libraries. You might be familiar with some game libraries like Raylib or Pygame. You might have used them in high school to learn about games programming. These are tools that extend the functionality of existing languages. Like Pygame works with Python or Raylib works with C, and you can use it to make very simple video games. They keep the amount of abstraction that they put between you and making the game to a minimum, so you can focus on the very fundamentals of game creation, stuff like putting images on the screen, making the window, managing collisions, and very low level things like that. They're good for learning initially, but as you scale up, the stuff that you'd be making in, say, a Pygame or a Raylib project is already done for you in engine with a bit more abstraction like Unity or Godot or Unreal. The reason that I chose to use something like Godot, and the reason I'm teaching you something like Godot today is that considering that you're either from the Game Development Club or the Computer Science Club, I assume you have some knowledge of programming already, just specifically not games programming or Godot. And I think that Godot gives you enough abstraction to be able to make things quickly, but it's still allows you to think about how to solve the problems of designing your specific game. And there are also a few other reasons why I picked Godot. It's free, it's open source. Making things in it is very fast and intuitive, which we'll get into why. And it has a very tiny install size, around 30 megabytes. By the way, if you haven't been downloading Godot, you certainly should. There's no installation. It's like a portable executable. All you need to do is download it and extract it. Right. So the question is, how does Godot work? Right. A Godot game is a tree, right? Similar to the data science structure, filled with nodes, scenes, and scripts. Those are the three components of a Godot game. Every Godot game is nodes, scenes, and scripts all the way down. And you can take any Godot game and break it into its nodes, its scenes, and its scripts, right? So let's start with the most atomic unit of a Godot game, nodes. Nodes are a fundamental piece of a Godot project. It's the smallest atomic unit, sort of. There are resources that are under it, but for the sake of simplicity, a node is like the smallest thing in your Godot game. Each node has a specific single function, and you can put them together to form complex scenes, right? For example, this is a character. Can you see my mouse, by the way? Just checking.
Yeah, we can see your mouse.
Okay, thank you. So this over here is a character that we've made in Godot, and inside of its scene, we put a area node, which allows it to collide with other areas, an animated sprite, which allows you to see it and play an animated sprite, as well as a collision shape, which allows it to collide with other areas, right? As I said, nodes are combined and put together into scenes, right? Scenes are simply bundles of nodes. You take a bunch of nodes together, you pack them into a scene, and you're able to reuse that scene in multiple instances, right? They're very helpful for managing instances of objects. For example, if you wanted to spawn a projectile, instead of having to make an area, a sprite, a collision shape, and a script every time, you could simply make that once, make a projectile scene, and then instance that scene every time. Scenes can also be placed within scenes, like in a sort of recursive manner, and that can go all the way up and down your project. It's very intuitive. Once you sort of learn how to make a scene, you kind of know how to make anything in Godot, at least. There are also scripts. Scripts are where you actually code your game, right? In Godot, you have the choice between using C# or GDScript. GDScript is a language specifically designed for Godot. It has syntax very similar to Python. We'll be teaching GDScript today because it is the more widely adopted and generally preferred language in Godot. If you attach a GDScript, you can attach GDScript files to nodes. I think if you go back, you can see, for example, here in the player, we have a script attached to it. That's what that little scroll icon means. Every script needs to be attached to a node in order for it to run, although you can load in scripts and run them within scripts, but we won't be doing that today. That's a little advanced. GDScript files allow you to store references to other nodes and scenes, run functions, manipulate node parameters, and send signals. Sorry, completely forgot to mention signals. Signals are also extremely important in Godot. A signal is a set of functions. Sorry, a signal is Godot's implementation of the observer pattern. If you're familiar with video game programming patterns, I assume you're not. What it essentially allows you to do is connect two separate pieces of your, it allows two separate pieces of your game to communicate with each other without being connected, which reduces coupling in your project and makes your code cleaner, right? A general mantra in the Godot community is to signal up and call down, because when you're dealing with a scene structure, you have parent scenes and child scenes. And generally, parent scenes are able to communicate with child scenes very easily because they're within them, but child scenes aren't able to communicate with parent scenes very easily. That's when signals would come into play. Okay. What we'll be making, this is a little game I cooked up. You play as a wizard who can shoot fireballs, and your goal is to defeat rats that are flying at you. So let's get started. Sorry. So first thing you want to do, don't mind my desktop. You want to open up the Godot engine, right? And when you open up the Godot engine for the first time, I think it will ask you if you want to check out some sample projects because it doesn't find any projects there. You can just press no, and you want to navigate over to this new project button. This allows you to make a new project. You want to enter in your project's name. Let's just call it workshop live because this is the one I'm doing live. And you want to navigate to the path where you want your project to be. Okay. It'll tell you if the selected path is not empty, and you can create a folder within that path. So now we have this here, and you get to pick the renderer. That's the first step that you need to do. You can change this later, but generally you just want to, for 2D games, you should just pick mobile, especially because it's a relatively simple 2D game. You can always change this later, and it doesn't really matter all that much. Okay, so the first thing you see, how do I get rid of the, okay, sorry. Had to move the zoom bar at the top of my screen. All right, so you open up Godot. Has everybody been able to open up Godot, by the way? Am I moving too fast? Everybody good? Can't see.
Yeah, the chat looks good.
Okay,
I'm
sorry. Yeah, I didn't see
on
the
the
chat. My
chat.
bad.
Yeah, I'm
I was
keeping
concerned there.
time, yeah.
Thank you, Fayaz. Right. So you open up Godot, and the first thing you see is a 3D editor, which is cool, but we are not making a 3D game today. You can make 3D games with Godot, and it's about the same as making a 2D game. It just takes a little longer. But what we want to do first is we just want to click over to 2D, and this gives us the 2D editor, which allows us to worry about making a 2D game. Okay. So a little tour of the engine, at least the editor. At the top right here, we have our scene tree. This is where you manage all of the nodes and scenes in the current scene you're looking at, right? Down here at the file system, this is the current file system of your project. And now that you mention it, now would be a good time to, actually, sorry, we'll add the assets when we need them. I don't want to give you too much stuff to worry about right about now. Sorry, so this is up here is where we manage our nodes and scenes. Down here is our file system, and to the right is where we manage node properties. For example, if you make a 2D scene, you don't have to follow along for this, right? But this is a 2D scene. It's just simply a node that represents a point. And you can see here it has a position, a rotation, a scale, and a bunch of other properties. And these are all properties that we can edit here, or we can edit in a script that we attach to it, right? So let's just delete this. Right, so the first thing that we want to do before we get started is I want you to go up to editor and editor settings. And I want you to enter type. Right down here in text editor, you can see completion and add, and there'll be an option to add type hints. This will be off by default. You want to turn this on because type hints are very helpful in programming in general, and they're off by default. So you want to make sure that you turn them on. Okay. So now that we've done that, I think we can get started with making our game. So the first thing we want to do is we want to make a main node. This is the node that will be at the root of our project, and every single node or scene that is in our game will be a child of this. So we can just click on 2D scene, and this will be a node 2D at our project, and we can double click on it, and we can just call it main. It's generally what I call it. You can call it whatever you want, but I just usually call it main. And to run our game, all you have to do is hit F5. So you hit F5 and you see this message. No main scene has ever been defined. Select one. You can change this later in project settings under the application category. This is just Godot asking us which scene is the scene you want to run first when your game starts, right? Because we didn't tell it which one, it's asking, oh, do you want this one to be the one that runs first when your game starts? So we can allow it. We can just pick select current, right? And it's asking us to save it. Generally, in Godot, I like to organize my projects into 3 sections. I like to organize them into the source code, the assets, and the resources. Source code is simply the code, the scenes, and the scripts. Assets is all of the visual and audio assets and stuff. And resources are something else that we won't get into in this workshop. But for now, we can make a source folder called src. And this is where we will keep all the code of our game. And we can just save main in there. Right. And as you see, we've run our first Godot project. Has everybody been able to run the project successfully? Is anyone running into issues? Okay, great.
So far so good.
All right, so we have our first Godot project, but it's not exactly very interesting. There's nothing on the screen. So let's try to rectify that. Let's add a player that we can move around. That's a good start. So what you want to do here is we can add nodes that are children of the main node. To do that, we can either press this plus up here, or you can press Control A. Right, this gives us a pop-up that shows us every single node in Godot. We won't be using that many in this project. The one that we are interested in right now is called a character body 2D. Right, we click on this one, and now this is a child of main. We can double click on the name to rename it to player. Right, and you still see that there is no player on the screen yet. That's because player is going to need a few children nodes of its own in order for us to actually be able to do much with it. So let's press Control A again, click while clicking on player, right? And we want to add a sprite 2D, not an animated sprite, just a sprite, because we aren't going to be animating them in this workshop. So press create, and we now have a sprite 2D. Okay, but there still is no image because we didn't tell it which image we wanted to use. We can see that there is a texture parameter here in the sprite2D's properties. So we'd like to use some of those assets that we downloaded and put them in our project now. An easy way to do that is to simply go to the file system, right click, and press open in file manager. Right, this will pop up, open your file manager, and I want you to take the assets folder that
By
you
the way,
have.
this is your file manager. We're not showing Jaden's file manager because that's his desktop files, right?
Yeah, sorry, yeah, your file manager. It opened up on my other monitor, which is why you don't see anything on my screen.
Yeah, like that's what I'm trying to tell the audience because like it didn't show up anything on the screen.
Yeah, sorry about that. Sorry for the confusion. But you simply want to make a folder called assets. Here, see? You want to make a folder called assets, and then inside of it, you want to put all of the assets that I had given you, right? Something like that. Okay, so we can now see here that it's updated in the file manager, and we now have assets. Okay, great.
You can
You want
also
to,
create it on the top bottom
yeah, you can
left
also
as
just
well
drag them
too.
in, and
Yeah.
then it'll create the
Okay.
sprite 2D, right? So now what we can do is we can click on the wizard because that's going to be our player character, and we can drag them over here. Okay, and as you can see, they are now on the screen. But there's a few issues we ran into. The first one is they're kind of small relative to the rest of the screen, right? So there are two ways that we can fix this. We can either make the screen smaller or we can make the sprite bigger. We're actually going to do a mix of both because I was experimenting and I found that to be the best size. So what we can do for now is click on the sprite 2D, go to transform, go to scale, and change the 1 to a 2. If you click on the X and change the X to a 2, the Y should also update to a 2. And now we can see that the wizard is slightly bigger. Great. We also want to change the size of the screen. So to do that, let's go into project settings. And in project settings, you want to go to window, right? The viewport width and the viewport height is the current size of the screen. In order to change that, you can just click on it and overwrite it. We're going to change it to, what are we going to change it to? Right, 640 by 360. Okay, so that's what we've changed it to, right? But one of the problems with this is that when we play the game, the screen is a little small, right? So we want the screen that the game actually makes when it's running to not be the same size as the screen inside of the editor. So to do that, all we need to do is click on advanced settings. Sorry, go back to project settings, click on advanced settings, and we can go to window width override and window height override. And this will allow us to make a different test width and test height. We can just set these to like 1080 by 720, which would be twice the size. And now if you see here, it should be perfect. Sorry, let me see something. This should stretch mode. I think this should work. as intended? Yeah, okay. Now it seems like it works fine. Sorry about that. You have to go to mode and change it to viewport. Go back to project settings, go to stretch mode and change it to viewport. And now you should see that the screen is twice as big when we test the game. Oh, okay. Sorry about that. Okay, is everybody sorry, is everybody following? What was the rest of the override? Oh, the override, you click on advanced settings to get the option for window width override and window height override, and you want to set them to 1280 by 720, which is twice as much as the size, right? And you also want to go to stretch mode and viewport, right? Okay. So we made this window smaller and we made the wizard bigger. But there's another issue you've noticed. The wizard is a little blurry. By default, Godot filters all of the art assets that you send into it. And this is pixel art. We don't really want it filtered. We'd like the pixels to be crisp. There's a pretty easy solution for that. All you need to go into project settings, and you need to go into, where is it? 2D render. Nope, not 2D render. What option was it? Textures. Oh, right. Okay, thank you. Sorry, in the default texture filter, you'd want to go to from linear to nearest, right? And as you can see now, goes from being blurry to crisp. Great. Okay, so we have our wizard, and he is looking good. Let's drag him into the center of the screen. So to do that, you want to click on the player, and then click on this little move mode button, and you just want to move him right to the center. Okay. So now we have our player at the center of our screen, but he still isn't really up to much. You can press F5 to run the game, but you can't move him or do anything. So let's fix that. We're going to have to make a script to and write some movement code. And we are also going to have to make some input actions so that the game can read our inputs. Go into project and go into input map, right? This is where Godot is able to record all of your input events. It's easier if I just show you than try to explain what they are. In here, we're going to have 5 inputs in our game, moving up, right, left, and down, and shooting. So we can make new actions for all of those. We can call one move left. Oh, sorry, move up, I guess, and hit enter to add it. And then we can make all the others. And shoot. Okay. So now we have 5 input actions, and we need to tell Godot which key we want to associate with each. Right. In this game, we're going to be aiming with the mouse and moving with the left hand. So let's use W, A, S, and D as our movement keys. So when we click on it, it says that it's listening for an input. We can simply press W. It'll record W. We can add it. From here, we can click on this one, and we can map this one to S for D. We can map this one to G for right, and we can map this one to A for left. And for shoot, it won't read it automatically because I'd want to use left click. So we can just click on left mouse button manually. If we go to the left mouse drop down and we click on left mouse button. Okay. And now we have all of our input actions recorded. Great. Now it's time to add a script to our player. To do that, all you have to do is click on the player, and there is a scroll with a green plus. We can click on that. Okay. And it's going to ask us to attach a node script. It's asking us what language you want to use, what class it's going to inherit, what its class name is, and its path. We can simply hit create. Okay. So now we're coding. All right. Godot is cool because the docs for what you want the docs for the entire engine is built into the engine. So you can simply press Control and click on any method or any class to get the documentation for it. So this is the documentation for the character body 2D. Right, a character body 2D is a specialized class for physics bodies that are meant to be user controlled. They're not affected by physics at all, but they affect other physics bodies in their path. They're designed for player characters, but they aren't always just used for player characters. Oh, sorry, can you go back to the previous step, attaching the node script? Sure. What you want to do for that is, if we're in this part of the editor, just click on the player, and you click on this green plus here, and it'll bring up this pop-up for attaching a node script, and you can simply press load, and it'll load it in. Okay. So back to the documentation. You can right click on any method or parameter, and it will tell you. And it will tell you all of its methods and parameters. The one that we're interested in for the character body 2D is this one, move and slide. You can click on move and slide, and it will give you the definition of it. It moves the body based on velocity. Okay. And if we look up here, if we go to properties, it has a velocity property, right? The current velocity in pixels per second here. So used in modified during calls to move and slide. So we want to use this to move our player around. Okay, so we need to set a velocity and then use move and slide to have the velocity be used to move the player. So to do that, we're going to have to write some functions. The two most fundamental built-in functions in Godot are ready. You don't have to follow along right now. Ready and process. Right. To keep it simple, ready is called initially when the node enters the scene, and process is called every frame, and it has a parameter delta time, which represents the time in between frames. So if you can multiply your calculations by delta time to make the movement in your game frame rate agnostic. Right. So what we're going to do here is we need to do a couple of things. We need to catch user input, and we need to have that influence velocity, right? Because the velocity is input is a speed and a direction, not just speed. So we can start by making a speed variable. So you can follow along now. We can just write variable speed. We type colon and equal. That's just a shorthand for automatically defining the type. And we can set that to, let's just set it to 100.0. Okay, cool. So now we have a speed of 100, and we can make another variable, which is direction. Let's just call it axis size, move direction, to not get mistaken when we start to use an aiming direction. This we can put a colon equals, and we can have vector2, which is a vector type, dot 0. So the move direction is going to be a vector based on our inputs. For example, if we were moving right, it would be a positive vector in the right. If we were moving down, it'd be a positive vector downwards. If we're moving left, it would be a negative vector to the negative vector in the x. Sorry. A vector is an x value and a y value. We're going to use it to represent which direction we're pressing. So to do that, we are going to make a function. Sorry. Let's start by using the process function. So I want you to type physics process. I know I just mentioned process, but physics process is essentially the same, except this is where you should make physics calls, because Godot does its physics stuff on a separate thread. It's not that important, but if you're using physics, if it involves stuff specific to physics bodies, use physics process. Otherwise, you can just use process. So in here, we want to run update direction function. So if you move direction is equal to update direction. Update direction isn't defined, so we need to define that. Yeah, it's going to throw an error. So we have some update direction where we are going to return the new direction. So let's do that. Sorry. Sorry about that. This syntax is simply telling Godot that we're trying to return a vector 2 in this function. Right. So in here, we need to return the updated vector. To do that, we are going to use the input class. If you look in the input class here, we can see that it has the function input dot, where is it? Get vector, right? Gets an input vector by specifying four actions for the positive and negative x and y axes. So we can pass in up, down, left, and right, and it'll return a vector that will tell us essentially where our direction should be pointing. Right? It says method. This method is useful for getting a vector input such as from a joystick, directional pad, arrows, or WASD. Okay, that's exactly what we're trying to do. So we can, it's a static function, so we can just type capital I input for the input class dot get vector. And as you can see, oh, sorry, if we look here, it says we need negative x, negative y, positive y. So we need to enter them in that order. So we have move left, comma, move right, comma, move up, comma, move down, right? It might make more sense for you to assume that up would be positive, but if you imagine this cross as being the Cartesian plane, the entirety of your game takes place in the fourth quadrant. So any upwards values, so any downward value would be positive, any upward value would be negative. It's like that for most game development engines, though. That's not a Godot exclusive thing. Okay. So we have a function that returns our movement direction. Okay, good. Just to check that it works, let's print it. So you can just type print and we can just type move direction. Okay. And now if you press F5 to run the game, you can see in the terminal down here, we can press directions and it should change, right? If you press W, A, S, and D, you can see that the vector is changing. And when you press a diagonal, it even normalizes it. So it would be the square root of 2 instead of being 1 and 1, which just makes it so that moving diagonally isn't faster than moving up and down. It's a nice quality of life feature. Okay, are everybody's vectors reading properly in the console? Okay, cool. All right, that's cool. We have some level of interactivity, but it's still not on the screen. And our goal was, again, to make him move. So we can remove the line where we print it just to not clutter the console. Okay. And all we need to do now, though, is just update the velocity. Velocity is speed times a direction. And we need to call the move and slide command, which tells Godot to move this guy based on his velocity. Okay. And now if we press F5, you should be able to move around. Is everybody moving around? Okay. All right, so we now have a guy and he is moving around, but there's a bit more to this game. We not only want to have a projectile to shoot, but we also want to make rats to dodge. So let's focus on the projectile for now, because that's not that much more difficult than what we had already done. So what I want you to do is I want you to go up to this tab here, and it allows you to make a new scene. I want you to go back to the 2D editor, and I want you to create a new root node. We're going to make a projectile scene, and we're going to instance it inside of our main scene, like I had described in the presentation. So what I want you to do is click on other node, because we don't want it to be a 2D scene, a 3D scene, or a user interface node. It should bring up the pop-up that shows you every node in the engine, and you can just type in area 2D. Right, this is the one that we'd like to make. Click on create, And we now have an area 2D here. Okay, this is going to be the base of our projectile. We can double click and rename this to projectile or just proj. And we can save it. You can save it in the source folder. All right, so our projectile is going to need a few things. Firstly, it's going to need a sprite. We can do that. And from here, we can drag in the projectile. Okay. And you should make sure to go to transform and set it to ×2 scale because everything gets increased by 2. Okay. And from here, we are able to attach a script to this projectile. So let's do that. Right. Click on create a new script, just like with the player, and we now have a projectile script. Okay. What I'd like you to do for this one is considering that this is an area and not a physics body, we have to move it a bit differently. What we're going to do is we are going to make a function inside of the player that creates an instance of the projectile, gives it a speed and an angle based on where our mouse is pointing, and then it uses that in a process function to move. So we can give it a variable speed. We set this equal to like 300. And we can have a variable angle, which we don't set. So this is equal to vector 2 dot 0. Okay. So now we have the speed and an angle. And in here, what you want to do is, well, for now, this is actually fine. We need to set up the function in the player first before we do anything else. Okay, so we want to have the player shoot a projectile based on where its mouse is aiming. How do we do that? Well, first we need to make a vector that stores where our mouse is aiming. So let's do that first. We can make var aim direction, and it's also a vector 2.0. And what we can do with that is we can update aim direction along with move direction. So we have aim direction is equal to update aim direction, which doesn't exist yet. We need to add that function update aim direction, which returns a vector 2. And we can have the code that gives us our aim direction in here. The reason I'm putting these in separate functions instead of leaving them in the physics process is that because your physics process runs every frame, it's very easy for it to get cluttered and for your code to become hard to read. So by abstracting it to only call different functions, it's much easier for you to maintain a cleaner game. In a game of this size, it doesn't really matter, but it's just a nice habit to get into. So it's telling us that we don't return a vector. We will. We just need to tell it to go return. And we need to use the function get global mouse position, which gives us the global mouse position minus position, right? So this essentially gives us a vector in between where our player is and where our mouse is, and that will tell us the direction that we're aiming. But before we use that, we need to normalize it. Normalizing a vector simply means that it won't be, the vector isn't longer or shorter depending on the length between the player and the mouse, which would make the projectiles go faster or slower depending on where your mouse is positioned, right? Which isn't our goal. So now we return that and we have an update aim direction and an update move direction. Cool. So we now have a function variable that stores the aim direction. Now we need to check when we press the shoot button. So what we want to do for that is we want to make an input event. So just you can just press function underscore input and it should autofill. It's an input event. An input event is simply whenever an input happens, Godot will call this function and it will go through it and it will check what the input was. And it passes in an event parameter, which is that event. So we can just check using an if statement, if event dot is underscore action pressed. You can press the arrow keys to navigate through the autofill. And it shows us all of our actions. We can simply press shoot. If input is action pressed shoot, remember we mapped shoot to the left button. We can make a projectile. So make projectile. Cool. This function doesn't exist, so let's just make that real quick. Make projectile. Okay. So what do we need to do in this function? Well, we need to make a projectile. We need to give it angle, and we need to put it in the scene. Okay. Let's break these down one at a time. The first thing we want to do is we want to give the player a reference to the projectile scene, so it knows it knows where it is, so it can make it. So up here, we want to write a projectile scene variable. We need to call it projectile scene like that, and we can load it in by using this load function, and this gives us every asset in our game. We can just press projectile.scene like that. Okay, so the player now has a variable that gives it a reference to the projectile scene. So we now know where that is. Okay, now in here, we want to make an instance of it. So call it var projectile is equal to projectile scene dot instantiate. How do you spell that? Sorry about that. Okay, like this. Okay. Projectile scene dot instantiate. This creates a instance of that scene and stores it in that variable. But that doesn't mean that it's in the scene yet. We still need to add it into the scene at a later step. Now what we can do is we can go projectile dot angle is equal to aim direction, which is the variable that we had made. And we want projectile dot position to be equal to our position, because the projectile is going to come from us. If we didn't do this, the projectile would always spawn at 0, 0, which isn't that helpful. And finally, what we want to do is we want to add it to the scene, right? So based on our current scene structure, right, the player is a child of the main node. So if we wanted to add the projectile to the game, actually, sorry, I'm getting ahead of myself. Let's just try adding the projectile to the game, right? Through add child, right? We can press add child projectile, right? And if everything worked out well, okay. All right, so there are a few issues here that we're running into. Let's see if we can break them down one at a time. Aim. All right, so firstly, the issue of the player being the parent of the projectile, as you can see, is even though they're spawning like all the way in the corner there, you can see that the projectile moves with the player because it's a child of the player. So in order to not do that, we should make the projectile a child of the player's parent. So in order to do that, simply add get parent, dot add child, my bad, like this. Okay. And this will add the projectile as a child of the player. Okay. And I think with that, yeah, okay. Now we can now spawn in projectiles, but they're not the most interesting projectiles considering they are static and don't move and don't do anything. But that's simply a problem with our projectile script. So if you go back to our projectile script, you can look at all the scripts that you have here. We spawn in the projectile, but it doesn't do anything. So we can fix that by using function process, right? And in here, we'll be able to add some code to make the projectile move. So to do that, first things first, we want to set the, oh, my bad. You want to set the rotation to the angle, because technically this angle is a vector. So we want to set it to an angle in radians. And we want to set the position to be equal to the speed times the angle times delta. We're multiplying it by delta because so that the projectile will be frame rate agnostic. Because we're moving it by a certain amount of pixels per second, if we were running this game on a faster monitor, then the game would be moving faster. But because we're multiplying it by delta time, it'll move at the same speed regardless of the frame rate. And now I think, yeah, the projectiles should work. Yay, we can now shoot at the rats that don't exist yet. Is everybody following? Yeah. As Zach put it, delta is the time passed since the last frame, which is a much easier. Can I see the main code again? No problem. The code for the player is here. I can just remove these. Could you show how to add inputs again? No problem. Go to project settings, and then we can go to input map. And then here you can click here to add a new action. Just call it action, right? And then it'll be added here. And you can simply click on the plus and it'll ask you to figure out which action you'd like to add to that, whatever event it is. For example, if it was pressing 2, right? Now pressing 2 triggers the action event, right? No problem. Okay, so we have a projectile, we have a player, and they're on the screen. But we need something to defend ourselves against. Let's make the rat invasion. In order to do that, we need to make some rats and we need to spawn them in. This code will be sort of similar to the projectile, but a bit more complicated because the rats aren't going to be spawning when we press a button. They're going to be spawning on a timer. So let's get about making that. It'll be the same root node. Sorry, click on the plus to make a new scene. It'll be the same root node as the projectile. So it'll be an area. And we can rename it to mob because it's generally what I call enemies. We can just save it. Cool. And we can give it a sprite. Okay. Right. Sounds good. Okay. Make sure to go back to the 2D view instead of the code view, and we can drag the rat in. There he is. Okay. Make sure to go to transform and multiply it by 2 so that it's not tiny. Okay. Sounds good. And now let us open up this. Let's add a script for the rat and add it in here. Okay. Just like the projectile, it will have an angle, which is equal to vector2 dot 0. Sorry, you have to put var in front. Okay, and it will have a speed. Which is equal to nothing as of now. So you can simply type float, so the engine knows that it's a float. As of right now, the only code that we're going to reuse the code from the projectile, so you can just copy and paste this from the projectile into the mob. Okay, so this is going to be the same because they're going to be flying around at a random angle, just like the projectile would. But there's a bit more to it than that. What we're going to have to do is we're going to have to go into main and we're going to have to make a spawning system. And to do that, we're going to use a signal. So go into main, click on the main node, add a new node. You can press the plus or press Control A. And I want you to add a timer, right? We can call this a mob spawn timer just to make it descriptive. And this timer is what we're going to use to spawn the rats in. What we can do now is go into main and add a script to main. And this is going to manage our entire game. What it's going to do here is we need to get a reference to the timer, make a function that runs when it ends, when it times out, and that function will be the rat spawn function. Okay. So now we need to do all those things. the first step is relatively easy. All we need to do is to get a reference to another node is to type @ symbol on ready, which is just a shortcut for saying we're going to run this inside of ready. So instead of, we could put this line in the ready function, but instead of that, we can just type on ready, which is a shortcut. You can put on ready variable, call it a mob spawn timer, and we can make it equal to we need to type get node, and we need to enter the path like that. And it'll now look through the tree and get the node at get node mob spawn timer. A shortcut for this, instead of typing get node, is just to press the $. And then you can just enter the name like that, and it's the same thing. Okay, we now have a reference to the mob spawn timer. Now in our ready function, we're going to have to connect when the timer runs out to a function. So how do we do that? We're going to have to use a signal. If you click on the timer, well, I guess I can just label this a timer for the sake of example, and then go to the documentation. We can look at all of its signals, and a timer has one signal, timeout, right? So we can, signals are things that you can, so that other nodes can subscribe to and listen to for when they happen. Imagine it's like the difference between connecting something directly and connecting it through a signal is like the difference between getting a phone call from someone and getting a tweet from someone, right? When you send someone a phone call, you need to have their phone number and you need to dial them directly. When you get a tweet from someone, all you have to do is subscribe to their Twitter account, and then whenever they tweet, you'll be able to see it. It removes a lot of the decoupling. Yeah, it's basically an event. That's a much better way of putting it. So if they aren't that complicated, once you start using them, you'll certainly understand. So let's go back to the main script here, right? We want to use our reference to mob spawn timer, so we can just put mob spawn timer, and we want to type the name of the signal, which is timeout, which runs when the timer runs out of time, and we can press .connect. And in here, we need to put the function that we want to connect it to. We need to call that spawn mob. Cool. And it'll say it's not defined. We can just define it down here. Okay. Oh, sorry, I didn't put a thing there. Okay. So we now have a function that is called when we spawn the mob. So for the sake of example, let's just put print mob would have, you don't have to follow along with this. Would have spawned in right now. Or I guess you can just put a little print statement here. And this is what's going to be called when the timer times out. So I guess we should make a variable to determine how long we want the timer to run for before it times out. We can have variable spawn time. And we can set that to, let's make it like 0.5 seconds. So every 0.5 seconds, a mob will spawn. And we need to, underneath our connection, we need to start the timer. So we have mob spawn timer dot, what is it called? Time. Sorry, let me look at the documentation to remember what the parameter is. Time left, I think. No, it should be wait time. Yeah, sorry, it's wait time. But wait time is what we use to define how long it takes, and that's equal to spawn time. Okay, so we set it to be a timer for half a second, and then we can just press mob spawn timer dot start. All right, and now when we start the game, you can see in your console that you're getting a message that's saying that a mob would have spawned in right now. Does everybody's signal work? All right.
is not working.
Okay, sounds good. So instead of printing a message, let us actually spawn in the mob. But to do that, we're going to need to do a bit more. Sorry, we're going to need to add 2 more nodes to the scene. This is going to be the most complicated part of the workshop, but if you've been doing well so far, then you can certainly do it. All right, we're going to need 2 nodes here. We're going to need a path 2D. So you can add that. I added it as if you ever accidentally add something as a child of what it shouldn't be a child of, you can simply click and drag to rearrange it. This is supposed to be isn't supposed to be a child of a timer. Okay. So we want to have a path 2D that we can call mob spawn path. And as a child of that, we can have a path follow 2D, which we will call mob location. Okay. What we're trying to do here is we are trying to make a line that is a perimeter of the game's screen. Right. And in doing that, we are able to make a floating point number between 1 and 0, which represents your position on that line. And from there, we can randomize that float to allow rats to spawn in from anywhere at the edge of the screen. And we'll do a little bit of math involving radians in order to get the rats to be shooting out into the screen and not away from the screen. So to start, I want you to click on mob spawn path, and you should see that these extra UI options appear up here, right? I want you to click on this green plus. It says add point and empty space. I want you to click on it, and then I want you to click on the 4 corners of your screen. You should see a path starts to be created. You click on 1, 2, 3, 4 corners, and then I want you to click here and close the curve. Okay. You'll know you did it correctly when you can click on mob location, and you can click on this progress ratio, and you can see as you scroll it from 1 to 0, you can see how it goes across the entire screen. Is everybody's path doing that? How do you undo it? If you like added a extra point where you didn't mean to, you can just press the X to delete it. If you want to move a point, you can press the mouse button. You can press the one that has the little cursor symbol, and you can just click and move it around, right? And you just want to align them so that they're at the corners. Right? So now that you have a mob spawn location and you're able to move it, and between 0 and 1 represents your progress on that line, we can now spawn some rats along that line. So let's go back to the script and go back to the main scene, right? We can delete this print statement because instead of printing a mob would have spawned, we want to spawn the mob. So to do that first, like the projectile, we'll need to get a reference to the scene. So let's go var mob scene is equal to load, and we can load in the mob scene. Okay, we now have a reference to it. Now we can type var mob is equal to mob scene dot instant. Sorry, I keep forgetting how to spell this word. Instantiate. They made it so complicated. It used to be a different word in Godot 3. Anyway, and then we can create, and then we need to get references to this location here, because we need to use this value to determine where the mob spawns. Right. So let's do that. Var mob spawn location is equal to this, is equal to mob spawn and mob location. See, so this gives us the child of this node. This is the one that we're interested in, right? And all we want to do is we want to take this progress ratio parameter and we want to randomize it. So we have mob spawn location dot progress ratio is equal to rand f, which you can click on the documentation, and it tells you that it returns a random floating point number between 0 and 1. And 0 and 1 is our range, so that works out perfect for us. Now what we want to do is we want to position the mob along that line. So what we want to do is we want to have mob dot position equal to mob spawn location dot position. Right. Now what we want to do, so now the mobs spawn somewhere on the line, right? They pick a random point on the line and they spawn there. Okay, cool. But we want them to be moving towards the inside of the screen and not away from the outside of the screen. So what we want to do is we want to get the orthogonal direction of the line, right? See if I just open a snipping tool. Yeah, let me just snip, right? For example, if they're on like the top, we'd want them to be moving this way. And if we're on the left, we want them to move this way. Over here, you want them to move like that. Over here, want to move like that, right? So we're going to have to do a little bit of circle math in order to get that done, but nothing too difficult. Let's go back to the scene here. We want to make a direction variable. Our direction is equal to mob spawn location dot rotation plus capital PI for pi, which is just a constant, divided by 2. Godot uses, can't infer the type of direction because it doesn't have a set type. You can just ignore the type hinting for there. Anyway, Godot uses radians by default instead of degrees. If you ever are more comfortable using degrees, you can just put the function rad2deg, which converts a radian to a degree. But generally, radians are just what they use by default. So I recommend learning them and becoming a bit familiar with them. What you're able to do now with the direction is that we now have a direction that is facing at essentially a pi divided by 2 rotation from where it was facing, which would be pointing towards the screen. Now we want to add a bit of a random element to it because we don't want every rat to be coming in at the same angle, which would be kind of boring. We can have direction is equal to randf range, which unlike random, my bad, sorry, tried redefining it. Direction plus equals randf range. And we can click on it and it says returns a random floating point value between to and from. So we can give it a range of where we want it to go. And we can set it to have a variance of, say, about like pi over 4. That's pi over 4. Okay. And now we can set the parameters of the mob like we would. We can set mob.angle to be equal to vector 2. Sorry, what are we doing here? Right. We're setting the angle of the mob. Instead of a float, we're going to give it a vector. So we just need to convert the direction angle into a vector. So to do that, we can just use a little math trick where we just get a vector pointing right and rotate it based on the direction. Cool. And now we have mob.speed. It's equal to random float of, let's give it a range between 100 and 200 so they can be as fast or as slow. Sorry, that was randf range. Okay, so there was definitely a lot in this function. Just to review, line 18 instantiates the mob. So we make an instance of the mob. It's not actually in the game yet. Mob spawn location gets a reference to the mob's location that we use to pick a random point. Mob spawn location dot progress ratio is equal to a random float, which gives us a random point on the line. The line is a perimeter around our screen. Mob position, we set the mob position to the spawn location. This direction, we take the rotation of where the mob is currently rotated and we rotate it by 2 pi, which makes it face towards the screen. We set the direction to have a little bit of random variance. We convert the direction angle into a direction vector, and we give it a random speed. Finally, because we're already inside of the main scene, we don't need to worry about getting its parent and adding it there. We can simply add child mom. Okay. And if everything went right, when you click run, you should have rats flying everywhere. Great. Okay. Does everybody have rats flying on their screen? Oh no.
What is doing here?
Sorry. Hello? Can't see the mob.angle line. Yeah, so here's the code. If you could paste your error into the chat, it could probably help. Oh, CME.gd. Yeah, this is sorry. Yeah, this is all of the code in the main scene. Let me zoom in to make it easier for people to see. Is anybody else running into any problems? Okay. Zach, did you solve whatever problem you were having, or do you need some more help?
Name player. Right. Uh, Typo fixed.
All right, cool. Everybody else's project's going okay? Nobody else
Kind
is
of.
running into any problems?
Mob scene. Line 13. INSTANTI. Taxation.
Okay, so I'm gonna continue on then. Cool. So you see that you can run your game and there are rats flying around, and you can avoid them and you can try shooting at them. And the issue is nothing's interacting with anything else. Sure, we have a what looks like a game, but nothing can actually happen yet. And that's because we haven't actually made any physics. We haven't made any areas. Oh wait, my projectile comes from my top left. You need to go into your projectile making code. Make sure you have the line that says projectile.position is equal to position. Go to player.gd. Let me know if that worked, Ryan. Same issue, but I have that line in there. Hmm. Um, is your projectile actually What it could be is if you go to projectile, like the scene, make sure that the sprite and the projectile are at 0, 0. You might have moved them to the center and that caused them to be offset. So when you open up the scene, make sure that they're at the top left corner. They are. Okay, and are you make sure that your aim direction line is the same as mine. Hmm. Um, it is. Uh, hmm. If it's top left, okay. Hmm. Oh, what it might be is you should check if your main make sure that your main scene is at 0, 0 as well. Is the projectile and the main scene are both at position 0, 0? Okay. Make sure that your sprite is at position 0, 0 as well, because you might have moved the sprite from the player, or you might have moved the sprite from the projectile. All right, okay, cool, good, yeah, definitely. Oh yeah, the sprite was moved. Yeah, an easy way to fix that. If you only want to move a parent and never the children, you can click on this here, which makes sure that the children aren't selectable within the scene, right? So whenever I click on node, it moves to the player. But a better solution than that would to just be to make the player a separate scene. So to do that, all we need to do is right click and go down here, save branches scene. And then we can click on source and we can save that in here. And now the player is its own scene and we don't need to worry about hitting any of its children. Okay, so the issue with our game is that nothing actually interacts with each other because nothing has an area for it to interact with anything else in our game. So to fix that, we need to give everything areas, which is actually quite simple. All we need to do is go to the player and add a collision shape 2D. This is a shape that represents its hitbox. So we can just click on empty new rectangle shape and sorry about that. We can just, oh, it's because this thing is on. You can disable the group selected nodes to make it easier for us to add this box that goes over the entire player. You can just drag it to fit. Like that. Although you can make it a little smaller, just so that it feels less unfair to the player. Like that could work. Sure. And that'll be the player's hitbox. So when the player gets touched by the rat, the game will reset. Same thing with the rat. We should give it a collision shape. And now here we can put it in like that. Cool. You can actually make the rat's shape a little bigger than the rat for the same reason that we made the players a little smaller. It'll feel nicer to the player. right? And finally, for the projectiles, the same thing. We need to give it a collision shape. So we can go collision shape, your rectangle shape, and we can just give it a shape like that. Okay, cool. Now we have a bunch of collision shapes, and now we can run the game, and everything should interact with each other. Well, no, because we haven't actually told it how to interact with things. They in the background, the collision shapes are on these things, and if you actually go to debug, where is it? Visible collision shapes. You can click that, and we can watch the game, and you can see that the collision shapes are there, and they are interacting with each other, but nothing's happening still because we haven't told it what to do when two shapes interact with each other. The easiest way to get it to discriminate between different shapes of different things is to simply use groups. To use groups, groups are just a way to label different scenes. To add a group to a node, you just click on the node. You can go to node, signals is here. You can go to groups. And then from here, we can just type in player. It's now in the player group. All right, we can do something similar with the mob, in the mob group. And projectiles are in the projectile group. Okay, great. And now let's let the code, now we should write the code that makes rats get, now we're going to write the code that lets rats be killed by your fireballs. So let's go about making that. What we want to do first is we want to use signals to tell when things have happened. We can check those by looking at the, sorry, if we just go here, go to okay, never mind. Collision shape. Is there a way to open documentation? Okay, thank you. Collision shape 2D. If we look at the collision shape, we should see that the signals aren't there. The signal is in the area. This is my mistake. Okay, go to the area. Well, you don't have to. Yeah, you can just look at my screen. Area 2D. It is a region of 2D space that detects other collision objects, 2Ds, entering or exiting it. And we can see in its signals, it has area entered, area exited, body entered, and body exited. We're going to be using those to run an event when the rat's hitbox it touches a different hitbox. So to do that, we go to the rat and we give it a ready function. Okay, and in here, we want to go area entered, and that is the name of the signal that is inside of area 2D. Area signal dot, sorry, area entered dot connect, and this is the function that we want to call. Let's just call it touching hitbox, right? And then function touching hitbox in here, pass it, and it doesn't throw an error, but when you call a function after the area entered, if we look at the docs, it'll probably mention it, but it expects an area, see, in the area entered signal. So we need to provide it that. So we can just go area 2D. So now we pass this area here is the area that we touched. So we'll be able to use it to check for things inside of the function, like if area dot is in group, and check if it's in group projectile, which is, I named that group, right? I named it projectile. Yeah, I did. Okay. Sorry. Check if it's in the group projectile. And if it is, well, we can just, let's remove the rat. So we can use Q free for that. And we'd also want to remove the projectile that hit the rat. So we can just also put area dot Q free. Q free is just a function that removes a scene from the tree. So if we run this now, we should see that our fireballs are now able to shoot the rats. Or is everybody able to shoot the rats in their game? All right, everybody's rats are getting shot at. Oh, sorry. This is the code. So this line here, we create a ready function. Sorry about that. We create a ready function, and in that ready function, we use area enter dot connect, and we connect the area to the touching hitbox function. And then down here, we define the touching hitbox function, which checks if the area is in the group projectiles. We clear the area, we clear the projectile out, and then we clear the rat out. Okay. All right, so with that, we now have the rats are now able to be defeated, but we want to also have the player be defeated when that happens. So what we can do with that is we can check if the player is being touched, but because the player uses a character body 2D, we need to make a different function for when it's touching the player, because it's not a hitbox. It's not like an area. Sorry, can I see the main code for a second? Sure. This is the main scene code. Let me know when you're okay.
That works.
All right, great. Okay, sounds good. Cool. So everybody's rats are getting defeated. We also wanted to be able to defeat the player, but because the player is using a physics body and not an area 2D, we need to use a different function called, we need to use a different signal called body entered. We can use body entered dot connect touching body, and we can do essentially, we can just copy and paste this. Although it won't be an area 2D, it would be a physics body 2D. And this is called touching body. Okay, and if area is in group player, we want to, instead of just like removing the player from the game, we can simply restart the game by using get free dot reload current scene, which is just a way for us to restart the game. Okay, so now when the player touches a rat, the game resets. Okay, great. Last but not least, let us make a score tracker. So we're going to have a label at the top of the screen that will tell us how many rats we've killed. All right. Also, we can add a background. To do that, let's add the background first, because that's pretty simple. All you need to do is go and add a text direct scene. It'll be at the bottom, and all you need to do is click on it and drag in the background. Okay. The issue is that the background is on top of everything. So to do that, to fix that, it's quite simple. We just click on the text direct and drag it to the top of the scene. And now the entire game will be on top of it. See? And now there's a little background for our game instead of gray. Cool. Last but not least, let's add the score label. To do that, we simply need to add a label. This here, labels are used to display plain text in your game. We can have it say score. Let's just drag it over here so it's a little easier to read. Actually, I think making it black would be easier to read. So to do that, all we have to do is go to the inspector, go all the way down to material. It's visibility. Go to visibility, modulate, and we can simply just slide this down. So now it's black. And we can now see that it will not track our score because we didn't tell it to, nor do we track our score at all. So let's go about adding that. To add that, it's quite simple. All we need to do is go to main, and we need to add a couple of things. Firstly, in mob, this mob function right here is where we check when this mob script here is when we check when a mob dies. So what we want to do is we want to make a custom signal. A custom signal is like a normal signal, except we choose when it gets emitted. Instead of it getting emitted when it touches a hitbox or when a timer runs out or when it touches a body, we just emit it ourselves in a code. So to do that, just type signal, call it died. And before we queue free, because if we queue free, we wouldn't be able to call it afterwards. We just want to go died dot emit there. And now we tell everybody who's waiting to do something after the died event that we just died and we should do something. So if we go to main, we can go here, we can go func update score, right? And we're going to have score plus equals 1, for example. Let's go up here and make that score variable for score equal to 0. Okay, and now we have a score variable and score is able to be updated, right? Not only that, but we also want to get a reference to the label for score label equal to label. And we want to go score label dot text is equal to score plus score. We convert score to a string and we just attach it at the end. So now the label will visually update whenever our score updates. But the only thing is we need to make sure that we run this update score function when a rat dies. A rat dies and it emits the die function, but we need to make sure that the main script is listening for that function. So the easiest way to do that is to just go to go into the spawn mob code, and before we add it, we can just tell it to listen for when it dies. So mob dot died dot connect update underscore score. Sorry. Like that. And now when we die, when we kill a rat, it should update our score. Let's go to the label again and just set it to 0 by default because the game will always start with a score 0. And now when we shoot the rats, our score goes up. All right. Is everybody's score incrementing? Got an error. What is the Ryan, what error did you get? You can just paste it in the chat. Invalid type of function connect. Are you calling? So you're calling the mob died dot connect after because it says cannot convert argument 1 from null to callable, which means that it's calling. Make sure that update score is spelled properly. Oh, okay, cool. Great. Yeah, so that's the game, I guess. Although we have a bit of I think we did a good job, you know. I think this is a cool game. You can shoot some rats, you can die. So that was an introduction to Godot. I thank you, Adam. How would I make it spawn from the center? Like, how would you make the rat spawn from the center? Oh, the player. Oh, for the player and to spawn in the center, all you have to do is take the player scene. Like, for example, if they spawn up here for now, we could move it down into the center here. Like just in the editor. Although there are a few improvements that we can make considering I think we have 28 minutes left. So there are a few extra things we can do. First, we can create a border so that you can't just leave the screen. To do that, it's actually relatively easy. We can just make a node 2D and we can call it borders. Right? And then from here, we just need to make some static body 2Ds. Now, static body 2Ds are usually used for like environments and stuff to be walls that you can't move past. So in order to make those, we need to make a static body and collision shape like that. And we can give it a collision shape. New world boundary. What? I didn't even know it was a thing. And it just does that for you? Oh, where did I go? Oh, it's because I'm stuck at the top. Wait a minute, what? All right, this might not be what I anticipated it to be. Okay, I have no idea what's going on. Okay. Sorry about that. What we can do is we can just make a rectangle as I usually do, and then just like drag it across. Right. What you want to do is we want to make another one on each side. So we can simply press Control D. 1, 2, 3, 4. And we can just move it around. One of them over there. And one of them over here, you can like, oh, right, because they're all the same shape. Okay. So what we could do is, because they're all the same shape, we can work with that because there are 5. There aren't supposed to be 5. You should just make it like a big rectangle, right? As big as the screen. Cool. All right. And you can just arrange them like that. So one is on each side of the screen like that. It's not the best solution, but it's the easiest. And yeah, now you should no longer be able to simply walk outside of the screen. Great. Okay. This is going wonderfully. Okay. Another thing that we can consider. In Godot, you have your scene tree here, as well as you have your scene tree when the game is currently running. The way that you're able to tell the difference between the two is you can just check to see all the scenes that are currently in your game, all the nodes that are currently in your game by going from local to remote, right? Although I think I got hit, so yeah, sorry. This allows us to see all the areas that are here. And as you can see that there are a lot of areas that spawn in very rapidly with all these rats. And one of the issues with our game is that when a rat gets off screen, it really doesn't matter anymore. And when a projectile gets off screen, it also really doesn't matter. But they just keep flying away in endless space. And eventually, if we don't clean them up, we will get a memory leak and our game will crash. So in order to do that, Godot has a very simple solution for just checking when something goes off screen. Let's go to the projectile. It's called a visibility enabler. So I know it's a visibility notifier, right? And all this does is checks if it's visible on the screen, right? You can see that there's a little shape here that represents the shape it's going to check if it's on the shape it checks on the screen, right? And from here, we can tell from its documentation that it has these two signals, screen exited and screen entered. So we can check when it leaves the screen. And when it leaves the screen, we can just delete it because it's no longer of help to us. So let's make a ready function. And we want to get a reference to it. So that's visibility notifier 2D dot screen exited dot connect, right? And this is when we would put in like a function, remove from game, and then we would write the remove from game function, and we would write queue free. But if it's a very simple one line thing like this, you can simply write functions within the connect. So we can just put function like that, and then queue free like this. So instead of having to make a separate function and then pass everything into it, this one liner will work fine. And we can actually just copy this and put it in the mob here, as well as give it a visibility notifier like that. Okay. And it won't really make much of a difference considering we can only see the screen, but now if it goes outside of the screen, it'll go away, and that'll help make your game better performance-wise. Okay. I think that is it. I think we got a lot done. I'm surprised. I thought we were gonna go over 2 hours, but we went about 1 hour and 38 minutes. So I hope you all enjoyed an introduction. Oh, you missed the border thing. No problem. To make the border, this is the solution I came up with. It's not the best one. You want to make I can just remake it for you, actually. What you want to do is you want to make a static body, and you want to make a collision shape 2D, right? And you just want to make the collision shape the same size as the screen. Like, oh, not that. I'm not, oh, sorry, it's because I'm in this mode. Okay. You want to make it approximately the size of the screen, right? And then what you want to do from there is you want to press Control D to duplicate it 3 times. And you just want to put 1 on every border like that. Okay. And now you shouldn't be able to leave the screen. Oh no, I can't even demonstrate it. Cool. But yes, this is the end of the workshop. Feel free to extend this project, try and add things like, I don't know, try to add a different weapon, try to add a different kind of enemy, try to add different levels. Maybe you could make it so that the rats spawn faster as time goes. There's a lot to do here. There's a lot that you can explore. I definitely invite you. If you run into any trouble, feel free to DM me on Discord. I'll be able to help you out. You can ask in the help channel in the GDYU Discord. You also probably will get help there. I hope you enjoyed. Yeah, be sure to join the GDYU Discord. We're very cool over there. We're playing Parappa the Rapper. Make sure to shout outs to Fayaz and Adam, CSHUB, for having me. Really appreciated it. Hopefully we can do some more collaborations in the future. So thanks everybody for showing up. All right. Okay, let me stop recording.